Hello all, welcome to the day 69 of the daily case study series for CBSE grade 10. The question goes like this. Read the following text carefully and answer the questions that follow. Two poles 30 feet and 50 feet tall are 40 feet apart, that is the distance on the ground, and perpendicular to the ground. So both the poles are perpendicular to the ground, which means that the angle between the pole and the ground is 90 degree. Then the poles are supported by wires attached from top of each pole to the bottom of the other. From A to F, there is one wire, and from E to B, there is another wire. So these two wires are coupled at a point C. A coupling is placed at C where the two wires cross. Let's observe the diagram. AB and EF are two poles. AB is 30 feet and EF is 50 feet. B and F are the points on the ground. The distance between the two poles, that is BF, is 40 feet. CD is a perpendicular from C meeting the ground at the point D, and it is marked as A. The distance between D and F is marked as X. Question 1. What is the horizontal distance from C to the taller pole? Horizontal distance from C to the taller pole refers to this distance. Let's say this point as G. Since the angles at D and F are 90 degree, CG and DF will be equal. So it is enough if we get the distance DF. That is, we have to find the value for X. To solve further, let us handle these two triangles separately. That is triangle ABF and triangle EBF. First, let us observe the triangle ABF. In ABF, we have a triangle FDC and the bigger triangle ABF itself. In triangle ABF, let's consider these two triangles. One is ABF itself and triangle CDF. Angle F is equal to angle F since it's a common angle. Angle at D and the angle at B both are equal to 90 degree. Angle ABF is equal to angle CDF. Both are equal to 90 degree. Therefore, by AA similarity, triangle ABF is similar to triangle CDF, which implies that DF upon BF is equal to CD upon AB. DF is X and BF is given in the question, which is 40, and CD is A, AB is 30. So from this we'll take A as 30 upon 40 times X. Now let's look at the other triangle BEF. In BEF, again we have two triangles. One is BDC and the bigger triangle BFE itself. Let's prove the similarity of these two triangles and then work with the proportionality of the sides. In triangle BEF, there are two triangles which we are considering for similarity. One is BCD and BEF. Angle B is equal to angle B. Angle BDC is equal to angle DFE. The reason being both are equal to 90 degrees. Therefore, by AA similarity, triangle BCD is similar to triangle BEF, which implies BD upon BF is equal to CD upon EF. Now, BD is this distance. So we get this distance by subtracting x from 40. So it is 40 minus x. 40 minus x upon BF is full length, which is 40, and CD is A upon EF is the second hour's measurement, which is 50. 40 minus x is equal to 40 upon 50 times a. Now instead of a, let us substitute 30 upon 40 times x. So 40 minus x is equal to 30x upon 50, which is 2000 minus 50x is equal to 30x, that is 80x is 2000. X is the horizontal distance from C to the taller pole. Question 2. How high above the ground is the coupling? This coupling C is at a height of A units from the ground. So that is, we have to calculate the value for A. Now that we know the relationship between A and X, that is A is 30 upon 40 times X. This is 30 upon 40 times X is 25, which gives us 18.75 feet. Question 3. How far down the wire from the smaller pole is the coupling? The question refers to the line segment AC. So we have to calculate the value for AC. For solving this, let's observe this triangle ABF. In triangle ABF, we have AB and we have BF's measurement. This triangle is a right angle triangle. Applying the Pythagoras theorem, we can get the measurement of AF. And from AF, if we subtract this CF, we will get AC. For getting that, we can utilize the smaller triangle CDF. Again, in the triangle, we have A and X measurement. So from that, we can get the value for CF. Then we can subtract and get it. In triangle ABF, AF is equal to square root of AB square plus BF square, which is root of 30 square plus 40 square, that is 900 plus 1600, which is nothing but 50. That is AF is 50 feet. In triangle CDF, CF is equal to square root of CD square plus df square, which is root of a square plus x square. A is 18.75, so 18.75 square plus x is 25, so 25 square. On further calculation, we get 31.25. That is, CF is 31.25 feet. AC is AF minus CF, which is 50 minus 31.25, which gives us 18.75 feet. The R part of the third question, find the length of the line joining the top of the two poles. The question refers to this length AE. Let's draw a perpendicular from A to the pole EF, meeting EF at say H. The line segment AH and BF are parallel to each other. The poles AB and EF are also perpendicular to the ground. So BF is equal to AF. If BF is 40, then AH is also 40 feet. Since we need this AE's measurement, we will consider the triangle AEH. AB is 30 feet, so HF is also 30 feet. From 50, if we subtract 30, we get EH as 20 feet. Now that we have 40 and 20, we can get the value for the hypotenuse AE. Draw AH perpendicular to EF such that AH is parallel to BF. Also, AB and EF are perpendicular to the ground. This implies that AH is equal to BF, which is equal to 40 feet. HF is nothing but AB, which is 30 feet. So EH can be got by subtracting HF from EF. It is 50 minus 30, which is 20 feet. Consider that triangle AEH. AE is equal to square root of AH square plus EH square. AH is 40. So 40 square plus EH is 20. So 20 square, which is 20 root 5 feet. That is, the distance between the two poles is 20 root 5 feet. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.